Hello everyone, welcome to this presentation that will be about Thoth's Python Cloud Resolver. And let's have a look at what we will talk about. So the whole presentation will be split into multiple parts. Here you can see the listing of these parts. And each part will have some demonstration of basic usage. There will be also links to articles that were published on developers.redhat.com. So if you are interested in details and technical aspects of solutions that will be discussed in this presentation, feel free to browse these articles and get knowledge about Thoth's Resolver. At first, we will talk about who we are, and then we will introduce the Python Cloud Resolver. The next section will be about using the Cloud Resolver, and then we will talk about extending the Cloud Resolver using a concept that is called prescriptions. Then we will take a look at containerized Python applications, and we will also dive into security domain. More precisely, we will talk about security of containerized environments, but also security about Python packages that are resolved by the Cloud Resolver. We will take a look at also cross-index resolution and how we can avoid dependency confusion attacks with Thoth. At the end, there will be links to references, so to articles that will be discussed, so feel free to browse them. The Python Cloud Resolver started in 2018 as a research project in Red Hat's AI COE, that was AI team, in Office of the CTO. If you are interested in this project, feel free to go to our homepage, that is ThothStation Ninja, and here you will find links to all the relevant sections in the documentation and also links to sources. The whole resolver is open source and also available publicly, so anyone can use it and anyone can contribute to it. The team pushes or publishes videos to a YouTube channel that is called ThothStation, so feel free to browse these recordings. And if you are interested in the news, feel free to follow ThothStation Twitter, that is ThothStation. Project Thoth itself is aiming to help Python developers and data scientists to create healthy applications. Thoth as a project does not consist solely of the resolver that we will discuss in this presentation, but there are multiple parts of the project, such as build container image build pipeline, dependency monkey for validating software stacks in a cluster, JupyterLab requirements, that is an extension for managing dependencies in JupyterLab. There are bots that manage GitHub repositories. Another part of the project analyzes container images, and there's also a self-hosted Python package index using Pulp. Okay, so let's go to the resolver itself and let's discuss it. If you are a developer and using Python, you are probably familiar with pip. That is the package installer for Python. That's the installer that is supported by the Python Packaging Authority. There are also other tools such as pipenv, Poetry, that enhance the management of dependencies, and also, for example, manage virtual environments for users or help with packaging of projects. Then there is a fourth resolver, that is Thoth. Unlike these three resolvers mentioned, Thoth runs in cloud, so the whole resolution process is not done on clients' machines, but is run in the cloud. And the main idea is that the resolver does not resolve application dependencies to the latest possible versions, but rather picks the greatest choices respecting the dependency graph and respecting the runtime environment where applications are run. This way, Thoth resolves not the latest software, but as mentioned, the greatest possible software that is considered to be the best choice for clients' applications. The recommendation engine is implemented using gradient-free reinforcement learning methods, so it's not a backtracking algorithm as in case of PIP, for example. And the resolver is, as mentioned, run publicly, available to the community. So we will take a look at how to configure your environment so that the resolver can be contacted from clients' machines, and how the resolver resolves application dependencies. As the resolver itself is picking the right software for clients, it can be seen more like a recommendation engine for Python applications, as it considers, for example, also what libraries users are using and adjusts requirements of the Python Cloud Resolver that are resolved by the public cloud resolver accordingly. If you are interested, feel free to browse documentation. This documentation is linked from the main page. So if you visit ThothStation Ninja, you can browse online documentation that talks about technical aspects of the project, but also how to set up clients' machines. So as stated, the Cloud Resolver does not run on clients' machines, but rather clients send requirements to the cloud where the Cloud Resolver is run, and the resolver considers application requirements that are sent and contacts knowledge or uses knowledge that is accumulated about application dependencies, resolves application dependencies, and provides back a log file stating each dependency together with digests that should be checked when installing application dependencies, but also justification. This justification states why certain decisions were done during the resolution process, and also some guidance why certain libraries were picked, and how users should behave when running the application and running or using libraries that were resolved by the resolver. If we take a look at inputs more closely, the input to the resolver are not just requirements, but you can also supply constraints that are known in case of resolution. So you can constrain your libraries or versions of libraries that should be resolved, but also information about software where the application will be run. This consists of operating system, Python version, base container image. Eventually, if a base container image is used, CUDA or other libraries that are used on clients' machines and could be considered during the resolution. The information sent to the resolver is outside of core Python packaging standards. So the resolver can really consider, for example, CUDA that is running on your machine, but the resolver can also consider, for example, CPU that you are running, or a GPU model if you are using GPU computations. As mentioned earlier, the resolver can also use information from static source code analysis. So if you use certain parts of libraries, the resolver can adjust the resolution process accordingly and can also guide on using certain parts of libraries. So users are aware of aspects of libraries as well. The last but not least input to the resolver is something that is called recommendation type. We will talk about it in demos, but basically this recommendation type states the intention with the application. So if you are a machine learning engineer who trains a machine learning model in an isolated environment, you want to have eventually a very well performing set of dependencies, and you are fine with possible security vulnerabilities because you really run your experiments and you are okay having a possibly vulnerable code in an isolated environment. On the other hand, if you are deploying your Python application to production, you would like to be sure that the application is vulnerability free and there are no known vulnerabilities that could affect security of your application. So these are the inputs to the resolver that are considered, and as mentioned, the resolver gives back a log file together with the justification that gives more information about the resolution process itself. Okay, so let's go into the next section that will discuss how the Python Cloud Resolver can be used. This section will introduce using Python Cloud Resolver, and if you would like to have really hands-on experience, feel free to follow a tutorial that is called Managing Security in Python Applications with the Thoth Cloud Python Resolver. This tutorial will walk you through the setup, will walk you through security aspects of the resolver. But if you go through this tutorial, you will also see how the resolver works and how you can set up your environment so that the resolver resolves application dependencies for you correctly. If you would like to use Thoth's Cloud Resolver, one of the integration points or one of the tools that you can use is Thamos. Thamos is a command line interface to the Thoth's Cloud Resolver. So really, it's a client tool that is running inside your terminal, and you can manage your environment and manage your dependencies, and you can also contact Thoth's Resolver. There are also other client tools that are provided by the Thoth team. For example, earlier mentioned JupyterLab Requirements that manages requirements in JupyterLab notebooks. But you can also set up Quebechead, that is a bot on GitHub that can manage your repository and dependencies that are stated in the application that is hosted in a Git repository. As mentioned earlier, Thamos helps with contacting Thoth backend. It collects all the information that is required for sending to the resolver to do actual resolution. If you would like to use Thamos, you can do so by installing it. You can pip install it into your environment. So just run pip install Thamos, and you can browse Thamos help, and Thamos config will help you with setting up your environment. Unlike other tools that manage application requirements, such as pip, pipenv, or poetry, Thamos manages multiple, let's say, runtime environments that can be eventually used with the application. This concept is called overlays, and in Thoth's configuration file, you can specify multiple runtime environments of your application. So eventually, if you want to run your application in an isolated environment to train a machine learning model, you can specify one runtime environment, which will ask for very well performing application dependencies, and the resolution process can give you back some requirements or some libraries that you should use in an isolated environment. Another runtime environment can be an environment where you push code to production. In that case, you can specify your own runtime environment that is specific to, let's say, prod deployment or inference. And in that case, you would like to have application requirements that are, let's say, not that performing, but on the other hand are secure and can be exposed to outside of the isolated environment. These two concepts are stated in the recommendation types. So you can specify recommendation type security, a recommendation type performance, and the resolution process will act differently. Another use case can be that you have same code, but you would like to have different requirements based on your use case or similar aspects. So this can be stated in overlays. Here is a screenshot from Thoth's configuration file. So you see there are two runtime environments. One is called inference. The recommendation type is set to security. You can see field information about operating system and Python version that is used. So in case of inference, we are installing Flask and TensorFlow in our environment. In case of runtime environment that is called for training, we also provide CUDA. So the machine learning model can be trained, and here you can see that you can specify, for example, Boto3 for downloading your data from S3 compatible storage, and then you can have TensorFlow that can be another or different build than the build used for inference, and that build can be optimized for machine learning training. So here you can see these two aspects or how to configure Thoth's resolver for two different use cases, but these use cases might share source code. In the demo, you will see more information about Thamos CLI, how to set up your environment, and how to use Thamos.
Welcome to the first part of the tutorial. In this tutorial, we will take a look at how to manage your application dependencies using Thoth's tooling, and how to use Thoth backend to resolve application dependencies and get insights on dependencies that you use in your project. Okay, so we are in a directory that is called project. Let's have a look at the content of this directory. And here you can see that we have just one file that is called app.py. If we take a look at the content of this file, we can see that it's a simple Flask application that is exposing hello world. Okay, so now we would like to use Thoth and Thoth's tooling to manage our application and application dependencies. For that purpose, we will need to install Thamos. That can be installed using pip install Thamos. After that command, you should have Thamos in your environment. Thamos is a command, so let's show its help. Here you can see various commands that are available in Thamos. And the very first command that we will use is Thamos config. What it does, if there's no configuration available yet, Thamos config will automatically generate configuration file for us. This configuration file is required to be able to use Thoth and Thoth's backend. So here you can see the content of the configuration file. One of the most important parts is runtime environments section, where runtime environments are configured. Here you can see that we have one runtime environment that is called Fedora 34, and it uses Fedora 34 with Python 3.9. That's the runtime environment that we are using now on the client side, and this was automatically discovered by Thamos and Thamos logic. So here you can see all the configuration options that are used and supplied to the resolution process. Moreover, we can adjust the configuration file based on our requirements. So here we can enable managing virtual environments in our application. Now we can save changes, and we should be able to see Thoth YAML configuration present in our project directory. Okay, so now let's use another command that is called Thamos environments. This command will show available Python environments for which we can do resolutions, and for which we can ask the resolution engine to resolve application dependencies. You can see Fedora 34 running Python 3.9 stated here, and there are also two other environments that you can use resolve your application dependencies. The other command that we will show is Thamos check. It basically checks that the configuration file is correct and things that are stated in the configuration file match the client environment, that is operating system, Python interpreter version, and things like that. What we can do now, we can perform or we can add dependencies to our project. So we know that we are using Flask, so we can call Thamos add Flask, which will add Flask as a requirement to our project. We can also use Thamos discover. This command will parse Python source code and will identify imports that are used within sources. So here you can see that there was identified import Flask that corresponds to package Flask. There was also created a directory structure for our runtime environment. So if we take a look at the content of our directory, we can see overlays. And if we check the content of overlays, we can see Fedora 34 and pip file that states one dependency, that is Flask in any version based on automatic discovery. Okay, so this was created automatically by Thamos based on the discovery. And what we can do, we can finally ask for an advice, so we can call Thamos advice. The Thamos will automatically collect information that are present in Thoth's YAML configuration file. It will also perform static source code analysis, collect direct requirements of our application, and it will submit it to Thoth's backend. So here you can see output that was computed by the backend, by the resolver. And here you can see two parts. One is application stack guidance, and the other one is recommended stack report. The application stack guidance state, let's say, generic information about our application. We can see warning that our Flask requirement has no version range specified, which might be a possible issue for future. We can also see two other warnings. One is that some Flask versions were removed because they are considered too old, and the other one is removing Flask in a specific version, more precisely in version 0.7, because there were spotted installation issues in the environments that we are using. Then we have recommended stack report. So here you can see also, let's say, generic information, but this generic information is specific to the stack that is resolved. And you can also see information about packages that we are using either directly or indirectly. So you can see informative messages for example, package click. You can find related links to, for example, project sources and things like that. And you can see this information for all the dependencies that are present in our dependency graph. We can call Thamos graph. That will show the dependency graph of our application. So here you can see Flask and as a direct dependency and all the transitive dependencies and how they were brought to our stack. So this is a Thamos graph. We can also show command that is called Thamos verify. That will check that the log file is up to date and corresponds to requirements that were stated for Fedora 34. So this was Thamos verify. You can also use Thamos provenance check. This command will submit the log file to backend and will make sure that backend verifies hashes, or backend will verify that the hashes stated in the log file are known. So we are consuming correct artifacts, and these artifacts are untouched. These hashes are also verified on client. during the installation, so you make sure that there is no man-in-the-middle attack or things like that. So this was Thamos provenance check command. What we can issue Thamos install. Now application dependencies will be installed, and Thamos will automatically manage virtual environment for us as configured in the Thoth YAML configuration file. Once we are done, we can run our application. So you can do Thamos run app.py, and here you can see that the Flask server is up and running and serving requests to the user. I was showing more commands than, let's say, needed in developer's workflow. If you're a developer and you are using Thamos, what you can do, you can simply perform Thamos add Flask, which will add Flask to your requirements, and then you can perform Thamos advice -- install, and this will contact the backend. The backend will resolve application dependencies, and once resolved, they will be installed in your environment. So here you can see that now the backend does not use cached results as in the previous command. This was intentionally because the backend also now considers the log file that was submitted and computed before. So the backend verifies that the log file that was present on client is correct, and application requirements are fine. So after that, you have environment up and ready to be used. Now let's consider that we would like to have two runtime environments for some reason. So imagine that we are running Fedora 34 as one runtime environment in our application, and the other environment is called UBI 8. Naturally, it will use UBI 8. And we can state the same hardware, or we do not need to provide hardware as desired. We can say that we are running Python version 3.8, and again, just for simplicity, that we are using recommendation type latest. If you recall from the presentation, we can have different recommendation types. So we can say that this runtime environment should have secure application dependencies, or it should have very well performing application dependencies, and this would be reflected in the recommendation type. So now when we do Thamos list, we should be able to see two runtime environments. The first one is Fedora 34. The second one is the newly added UBI 8. Now what we can do, we can add Flask and TensorFlow to our runtime environment that is called UBI 8, and this command will add requirements Flask, TensorFlow to UBI 8. It will also create a directory structure for the desired runtime environment. If we take a look at the content of overlays directory, we can see that there's UBI 8, and we have pip file that is stating TensorFlow and Flask as configured. So this runtime environment has different requirements on dependencies that we are using. Now we can call Thamos advice on runtime environment UBI 8, and this will again collect information about the environment from Thoth's YAML configuration file, but will also use the UBI 8 as a runtime environment for managing our requirements. So we can wait for the backend to finish computation and resolve application dependencies. This should be pretty quick. It depends on the system load and also on the recommendation type. So the latest recommendation type is not really the fastest, but you can ask for performance or or security, and these recommendation types can take some time to find the most suitable log file for your application. So here you can see more verbose output because we have requirements such as TensorFlow. So you see TensorFlow brought a lot of packages to our software stack. Moreover, you can see all the details about these packages that were brought to the environment, and you can also see that application stack guidance is somehow larger as it considers also like removes versions of TensorFlow, for example, that were causing issues in the target environment. Okay, so now if we take a look at graph for UBI 8 environment, you should be able to see the dependency graph. You see that the dependency graph is more verbose. There are folded parts of the dependency graph that are shared. So if you want to see the whole dependency graph with shared nodes, you can see that we have Flask and TensorFlow as our direct dependencies, and then there's Flask subgraph and TensorFlow subgraph that is pretty large. Okay, so this would be probably it, and we can continue with presentation.
So the demo showed contacting Python resolver and also setting up your environment. In the next section, we will take a look at declarative interface for the resolver. So the resolver can be configured to resolve application dependencies following prescribed rules. If you are interested in this concept, feel free to check article published on developersredhat.com. The article is called Thoth Prescriptions for Resolving Python Dependencies. Okay, so the resolver itself is designed as a resolution pipeline. This pipeline accepts input on the input that is sent to the public cloud resolver, and the pipeline produces the mentioned log file and the justification that is the output of the resolver. As the whole resolution is seen as a pipeline made out of pipeline units, each pipeline unit can somehow affect the resolution process. There are pipeline units of different type, and these pipeline units can insert new dependencies into the dependency graph. They can prioritize some packages over other packages. They can fix overpinning issues or underpinning issues, or they can consider requirements on the runtime environment outside of the Python packaging standard. So, for example, a pipeline unit can adjust resolution of TensorFlow version, considering CUDA version that is present on the client's machines. So these are the pipeline units types. And these pipeline units can be implemented directly in Python for very specific cases, but Thoth's Cloud Resolver also provides the declarative way how to express how the resolver should look like, or how the resolution in the resolver should look like. This declarative interface is called prescriptions, and the prescriptions are in fact YAML files that are consumed by the resolver. If you are interested in prescriptions, you can check already available prescriptions on ThothStation organization inside prescriptions repository. And these prescriptions are prescriptions for open source Python packages, and provide a way how to adjust the resolution process, and also give more insights about dependencies that users use. As stated, they are just YAML files. They should be pretty easy to read by users. And if you would like to write your own prescriptions, you can follow documentation that is also linked from the main page that discusses about these prescriptions, also mentions what type of pipeline units are available, how to write them, and how to express what is needed in the resolution process to correctly consume these prescriptions. If you are familiar with OpenShift or Kubernetes, you can see these prescriptions as an analogy to manifest files used for deploying applications inside clusters. So prescriptions really state or provide a way how to declare desired outcome of the dependency resolution, similarly as OpenShift or Kubernetes manifest files state the desired state of a cluster. So let's have a look at some of the prescriptions. More closely, we will take a look at one prescription here, and the follow-up demo will show the prescriptions repository and some structure of this repository and some prescriptions. There's a known issue. Pillow in version 8.3.0 does not work with NumPy. So if you use these two libraries, you get a runtime error. If you use these two libraries and you encounter this runtime error, you need to check what's wrong and how to fix this problem. As this problem is already known and this knowledge about this issue could be encoded somewhere, then users of these two libraries can be freed of checking what's wrong on their system and eventually searching for a solution to this type error. If there would be a way how to express this issue directly during the resolution process. So when people ask Pillow and NumPy, the resolver itself makes sure that these two libraries that collide in specific versions are not resolved together. Then users can really focus on their code and really deliver solutions for using Python and these Python libraries. Here you can see an example of a prescription. So it's a YAML file. Each prescription starts with units. As mentioned earlier, there are different types of pipeline units. So you can write multiple pipeline units as desired and multiple type of pipeline units. This time there's a step pipeline unit that is called Pillow 8.3.0 type error step, and it's of type step. It should be included during the resolution, and this is matching criteria. So if resolver resolves Pillow in version 8.3.0 from PyPI index, then and encounters NumPy in the resolution process, it says to the users that the given resolution process is the given resolution path is not acceptable. Prints warning information a warning to users together with a link to issue, and the resolver itself tries to find another resolution path that would not suffer from this issue. So we'll eventually find another Pillow version together with NumPy, which does not have this issue, and eventually others. Okay, so let's have a look at prescriptions and the prescriptions repository.
In this part of the tutorial, we will check concept that is called prescriptions. If I recall correctly, we use Thamos Advice to advise on our application requirements, and Thamos Advice collected information from the runtime environment, from the client's runtime environment, and submitted it to the backend, which computed recommendations. The computed recommendations were brought to the client, and there was also a so-called justification. So that's something you can see printed in the terminal. This information is split into two parts. The one is recommended stack report, the other one is application stack guidance. You can see information for each package that is used inside the application, and possible security implications or other implications that are there when using the open source packages. There can be also printed messages when it comes to the actual resolution process and information what actions were then done by the resolver itself during the resolution of our software packages. Thoth resolver is designed as a pipeline, so when resolving application dependencies, a dependency graph, each package goes through a resolution pipeline, which is made out of pipeline units that can be of different type. And these pipeline units decide whether a package should be scored positively, should be scored negatively, or should be discarded from the application stack. And the resolver should look for another resolution path to satisfy application requirements. Moreover, this pipeline can fix underpinning, overpinning issues, supply alternatives to the resolution process, things like that. So it can do all these magic things on the application dependency graph. Some of these pipeline units are implemented in Python code. In that case, the resolver needs to carry corresponding Python implementation that adjusts the resolution in some way, but some pipeline units can be declared using prescriptions. So prescriptions is a concept that is brought by Thoth resolver, and if you take a look at Thoth Station organization on GitHub and you go to prescriptions repository, you should be able to see a repository which has prescriptions directory. And this directory is structured so that these prescriptions are available. So, for example, we can check security warnings that are warnings related to standard library. So, for example, we can check prescription that is called HTTP server, and this prescription acts on during the resolution. So, for example, if we would like to have secure recommendations, but the application uses http.server, the resolution fails with error that HTTP server is not suitable for production use. So that's one security-related aspect of the application, which will avoid using HTTP server when people ask or developer ask secure recommendations. On the other hand, other recommendation types can be or accept using HTTP server as desired. We can also check other. So, for example, we have pickle. Pickle library is considered to be vulnerable. So in some cases, so you should consider restricting globals when using pickle. These were security warnings on the standard library. You can also find other prescriptions. So, for example, here are prescriptions specific to container images that can be used during application development. So if you use Python applications that are containerized and use base container images which are supplied to the resolution process, Thoth resolver can act on these container images and, for example, warn about possible security issues. So once the content is loaded, you can see that there are vulnerabilities reported or found in the base container image, and you can find more information about these vulnerabilities in the linked pages. Okay, so these were prescriptions on container images level. You can have prescriptions specific to Python package indices, or you can have prescriptions specific to packages. So let's consider, for example, TensorFlow package and prescriptions that are available for the TensorFlow package. You can see information aggregated from open source security scorecards but you can also find other prescriptions that are supplied to the resolution process to, for example, fix issues caused by library overpinning, or you can find other issues fixing, for example, issues with other libraries and clashing libraries and things like that. So you can really find prescriptions for per package, but also on the base container image level and prescription specific to indices. This prescriptions repository acts as a database, so it's free and open to everyone. You can contribute to this repository and you can write your own prescriptions. If you follow documentation that is linked from the repository, you can find more information together with examples that can be suitable as a starting point if you are new to this prescription concept, and also documentation how you can write your own prescriptions and how you can adjust the resolution process of open source Python libraries so that the resolver, the public cloud Python resolver, gives you the best possible recommendations on how to use your Python libraries.
The next section of this presentation will talk about containerized Python applications. So before we talked about resolution process that is specific to Python libraries that are resolved, but Thoth Cloud Resolver can consider a base image or base container image that is used together with application, so that the resolver can really synthesize Python layer of the application together with the base container image that provides a software environment in which Python libraries are running. If you are interested in details, feel free to check Build and Extend Containerized Applications with Project Thoth. It's an article that is published again on developers.redhat.com, and it will guide you through the process and how the resolver considers different libraries, considering also containerized Python applications, how it analyzes containerized environments, and how these containerized environments are built using AICoE CI, that is CI, another part of Thoth. Okay, so the resolver really tries to fit the containerized environment. So we have application dependencies that are resolved on Python layer. The application again can be a Python application, and this application uses dependencies. Python projects can use, for example, native dependencies that can be installed using RPM, or these dependencies can rely on certain API to be present in the runtime environment, for example, glibc. Dependencies such as TensorFlow or PyTorch might require CUDA to run GPU computations, and there can be other requirements on the runtime environment such as OpenMKL, CUDNN, and others. So it would be really good if there is a resolver that can consider and synthesize these application and application dependencies that are solely on Python level together with runtime environment, the base container image in this case that is used. This is the thing that we will talk about is an extension. So you can still have generic Python resolution that is very similar to pipen for poetry when using Thoth. But if you provide information about the base container image that is used, Thoth resolver can take a look at the environment that you are using with your application and synthesize application dependencies and runtime environment. Here you can see a stack that is used to run an application. So let's consider that we are running a Python application, but if you are running a Python application, most probably you rely on some Python dependencies that can be direct dependencies of your application, but also transitive dependencies that are brought as dependencies of your direct dependencies. These Python layer can use native dependencies and runs inside some Python interpreter. This Python interpreter can be in a specific version, so it can be Python interpreter version 3.8, 3.9, 3.10. Native dependencies required could be, for example, Git to be present in the environment if you are using a dependency that manages Git and Git repositories. Or it can be a native dependency like CUDA for communicating with hardware and operating system and operating system kernel modules. Operating system itself creates another layer that is in kernel space, unlike user space that we've talked about, and this all software runs on top of some hardware. So there's also hardware configuration like GPU cards that you are using or CPU that you are using that can have some features that your Python application can use, such as AVX2 instruction sets, so that your native code can be executed faster. This is the whole stack, and this is how the whole application, Python application can run. Of course, if there's an issue in any layer, your application might misbehave, might produce wrong errors. So if there is a way to resolve your application dependencies and also guide on your Python application in a same way, developers can be freed from issues and freed from debugging code that they could eventually not even wrote. So, as stated, we have a base image. This base image provides an environment. Thoth itself provides multiple base container images. These container images could be, let's say, vanilla container images for running Python code, but they can also include additional libraries that are ready to be used, and the containerized environment provides, let's say, predictable stack that is tested and is known to be operational for desired purposes. And there are also other containerized environments such as JupyterLab and others. You will see some of them in the demo. The goal of the Python resolver is really synthesize what's already present in the containerized runtime environment together with resolved application dependencies. Here is another picture how you can imagine. So you have a base container image, you have the Python environment of prepared Python environment that is known to be operational, or if there are any issues, these issues can be known or reported, and the resolver can act on them. Then the resolver recommends Python libraries that are installed into this Python environment and into this base container image, and gives additional stack level guidance, so you know that the whole stack works well, not only on software level, but also eventually on hardware level. If we want to give more examples, or if we want to give an example, let's say we have a containerized environment that is known to be operational and working for natural language processing, and it's used and it is using TensorFlow in some specific version. Now, let's imagine that a machine learning engineer wants to visualize how model performs, and would like to use TensorBoard for that purpose. TensorBoard is not shipped inside the predictable stack, inside the containerized environment, and that way can contact Thoth's resolver. The machine learning engineer can contact Thoth's resolver, and Thoth's resolver will know this predictable stack, the containerized environment that the user uses, and will suggest to use the most appropriate TensorBoard version that can be used inside the containerized environment and will work. For example, considering TensorFlow version or versions of libraries that are already present in the containerized environment. If you would like to use containerized environments, Thamos, the command line interface, allows you to list containerized environments, images. You can do so by running Thamos images. You can additionally query these containerized images. So you can query, for example, based on Python version that you would like to use, based on CUDA version that you would like to use, based on symbols that are present in the containerized environments and are required to run your application, or RPM packages that are shipped inside these containerized environments. Okay, so let's take a look at a demo.
In this part of the tutorial, we will take a look at how we synthesize base container image together with requirements on Python libraries that our application has. So in this tutorial, we will use our application that is a simple Flask application. So what we can do, we can trigger the recommendation engine again by asking for an advice, and the recommendation engine, once it computes results, will show us information about libraries that we use and some additional information. So here you can see the information provided by the recommendation engine. What is important for us is that the recommendation or the recommended stack was computed based on the latest recommendation type. If you take a look at our requirements, we have just one requirement, that is requirement on Flask. Now what we can do, we can adjust the configuration file, and we can state that we don't want latest software stack, but we want to have secure software stack, meaning our application dependencies should be secure. We can again schedule the resolver and ask resolver for an advice. So again, the resolver will compute recommendations for our application and will provide us information on the libraries that we use, but this time these recommendations will be specific to security. So security aspects of our application. So again, you see information about the libraries that we use, and if we scroll up, you can see a new entries in the first table that is called application stack guidance, and these entries basically state which packages were skipped in the resolution process or were removed from the dependency graph and were not considered during the resolution because of known CVEs that are used that are known to the resolution process. These CVEs are taken from the advisory database that is published by the Python Packaging Authority. So here you see these aspects of security of our application. And now let's take a look at what base container images we can use with Thoth. So we can ask for a listing of container images by performing Thamos images, and Thamos will give us back information or listing of containerized environments, prepared containerized environments that we can use with the application as we want. We can also follow container image analysis, which will give us back information about software that is shipped in these container images. So let's say we pick one container image, and we can adjust the configuration file so that we state that we are using a base container image to run our application. So here we can state base container image that we use. We can use any prepared containerized environment based on our needs. So in this case, we are using TensorFlow that is prepared environment for natural language processing. Okay, so we stated this configuration in Thoth's YAML file. This configuration was adjusted manually, as you can see, but if you run Thamos Auto Discovery and you run the base image, Thamos will automatically discover the base image that you are using, so you are freed of this manual work. Now what we can do, we can schedule resolver again and ask resolver to resolve application dependencies specific to this containerized environment. The resolver can take into account what is shipped already inside the container image. So for example, RPM packages or ABI or Python packages that are already shipped in these container images, and can resolve application dependencies specifically for this base container image. However, in this case, the resolver failed. It failed because it found a vulnerability in the base container image. This failure was expected because the base container image is vulnerable to some this vulnerability, and we declared that we want to run secure applications by providing recommendation type security. If there would be a base image that is shipped by Thoth that is vulnerability free, the resolver will suggest us to use that base container image that is vulnerability free. As there's no base container image in other versions that would be vulnerability free, in this case, there are no recommendations on the base container image. In the meantime, I've adjusted the configuration file so that we get latest recommendations. As you can see, the resolver was successful in this case, and you can see a listing of Python packages that were resolved considering the secure application. What you can also observe is that we have a listing of vulnerabilities that were found in the base container image. In this case, it's just a warning because we ask resolver to use latest recommendations. If we are okay with running this application, even if there are vulnerabilities, that's fine, but we should consider these aspects of the software that we are using and the containerized application is running in.
In the next section, we will talk about security. Security is an important aspect when shipping your applications. The code name for Thoth is also AIDevSecOps. And if you're interested in security and how Thoth can guide you with respect to security, feel free to browse article that is called Secure Your Python Applications with Thoth Recommendations. This article is published on developers.redhat.com. Some parts of these articles are, let's say, not up to date, so follow also online documentation of Thoth's resolver that are this documentation is available from Thoth's main page. Okay, so here you can see also the link to the documentation, Thoth security advices, and the resolver can perform security-related suggestions on your Python application. These suggestions can be specific to Python libraries. These can be also specific to Python standard library. So if you are using some possibly vulnerable parts of the standard Python library, you can be warned about this fact when using Thoth's resolver. And you can also be warned about known vulnerabilities in the Python ecosystem. This aspect is derived to you thanks to the database that is called Advisory Database, that is maintained by the Python Packaging Authority and is periodically updated on Thoth's site. So if there are known vulnerabilities in Python libraries, Thoth automatically syncs them and warns you about using possibly vulnerable live open source libraries. Another source of information are security scorecards. These scorecards are published by the Open Source Security Foundation, which performs analysis on GitHub or Git repositories, and you can find interesting information such as if a project signed releases and things like that. You can see examples linked. To synthesize again, Python layer together with the base container image level, Thoth also aggregates information about vulnerabilities that are spotted in the base container images. So if you are using prepared container images by Thoth, these are automatically analyzed and known vulnerabilities are reported. This way, you are sure that the application dependencies can be vulnerability free with respect to known vulnerabilities, but also the base container image, the environment, the runtime environment that you are using to run your Python application and Python libraries is vulnerability free. So again, synthesizing Python layer together with containerized environment level. There are also additional information on packages that you are eventually using, and Thoth Resolver guides you on usage of these libraries. Such information can include information about behavior of community. So if there are very few maintainers of a project, that can be possibly a security issue in your application, or if the community is not active or the project is no longer maintained, that can be also a security issue, and developers and users could consider using such libraries in their production code. Most importantly, if you specify the recommendation type configuration option to be security, the resolver blocks using possibly secure environments. So it really prevents from resolving application dependencies and possibly blocking pipelines that are installing Python dependencies, so that your code that is pushed to environments that should be secured are vulnerability free and are not prone to known vulnerabilities. This way, you can be sure that the resolution engine will really guide you on security and security aspects of your code. Okay, so let's have a look at a demo that will demonstrate security aspects of Thoth.
What we're going to do now is see how Thamos can help you see a vulnerability in a simple application that we implemented, which is a simple version of Conway's Game of Life, if you know the game. So you can have an overview of what Thamos can do by typing Thamos help, and you should see here the different commands that are available. So we have a configuration file, which is called .thamos, where you can state, for example, your operating system version and your Python version and the recommendation type you would like to have. So the default recommendation type is the latest. So it means the latest version of dependencies are chosen for your application stack. So what we're going to do is now ask Thamos for advice on our software stack application. So I will do Thamos advice. So, okay, here you can see several things. So apart from the warnings, you can see a table, which is the application stack guidance, which has different type of information and warnings with a message that can give you some advice. So for example, on what predictable stack we have for you available, and different links just to see more information about this message. And you can also see the recommended stack reports. So for each dependency name, you have different information and warnings about, for example, some vulnerabilities or issues that you can have, for example, on these dependencies. Okay. So now we're going to install the dependencies with Thamos install. So here you can see the py.log file. Okay. So you see, as you can see, we have different dependencies like async click, pillow, and pygame. So now what we can do is run the game just to see how it works. So we'll do Thamos run game of life. Okay, so now we can see, I hope so, the game interface. And so the game of life, I don't know if you're familiar with it, but it's just selecting a few first individuals and then let them reproduce on several generations according to some rules. So here you can have an example that I will show you later how you can detect vulnerabilities in the dependencies of this game. So you can also have an overview of what Thamos has done by typing Thamos log, which will generate the logs of the resolution process. Okay, so now the part where we introduce a vulnerability to see if Thamos will detect it. So what we'll do is introduce pillow in the version that has a known vulnerability, which is 8.0.0. So we add this to our dependencies. So you can see it has been added here. And now we'll ask Thamos for advice. So I will do Thamos advice, and I will choose the recommendation type security, because it was set on latest as a default. So now that's doing the resolution. Okay, so now what you can see at the bottom of the terminal is that pillow could not be resolved because you asked for a secure software stack, and the dependency version you wanted has a known vulnerability, as you can see here. It was found with the PI advisory DB database. So now you can't solve your application software stack. So what we can do now to play the game is revert to a version that does not have any known vulnerability. So I think this is the latest version of Pillow, which is 9.0.0. Okay, so now it is changed back to a correct version, and now you can do Thamos run game of life. And you can see that you can play the game again. Now it's working properly.
So thinking one addition to that, so you saw that the pillow was pinned to a specific version that had vulnerability. If Maya would not pin that specific version, the resolver itself would find a vulnerable free version of pillow, if that would be possible based on the dependency graph of the application.
Now let's take a look at cross-index resolution. If you are interested in this topic, feel free to check Prevent Python Dependency Confusion Attacks with Thoth. This is an article that was published on developers.redhat.com and discusses dependency confusion attacks and solutions that Thoth gives you. Thoth, as a cloud-based resolver, can be configured by Thoth operator to monitor multiple Python package indices. So it can be configured to monitor package releases on different indices. So let's say it can be configured to monitor releases done on PyPI. Thoth can also be configured to monitor releases on a PyTorch index, on another index that can have, for example, optimized TensorFlow builds for specific CPU instruction sets, but can be also configured to monitor packages published on company indices, like multiple company indices, such as and hosted by Pulp. If you are interested in hosting your own Python package indices, feel free to check an article that is called How to Self-Host a Python Package Index Using Pulp. As Thoth monitors all these indices and checks what packages in what versions are released on these packages, it can guide the resolution process so that users use the right software. So if you have, for example, AVX2 enabled CPU and you would like to use AICOE index, Thoth can transparently do that for you. So considering that your CPU has AVX2 instructions, Thoth can suggest you to use AICOE builds of TensorFlow. If you are running, for example, PyTorch and your environment has CUDA in version 11.1, Thoth can guide the resolution process in a way that you get PyTorch releases that are specifically built for this CUDA release. These builds are published on the PyTorch index and not on PyPI. So Thoth can really pick the right source of your software that you can use in your application. This is the enhanced knowledge of software. To support this, Thoth needs to automatically monitor new releases. It's automatically done by its background data aggregation and data ingestion logic, and can guide on using these libraries even outside of many Linux standards. So you can specify which releases should be used for AVX2 optimized, for AVX2 enabled environments, which releases should be used for CUDA specific environments and things like that. The dependency resolution is done in a way it is not prone to dependency confusion attacks. So Thoth's log file states which Python package indices should be used for installing Python packages together with hashes. This way, Thoth is one central point, one knowledge of Python packages, and the cloud-based Python resolver knows which packages should be picked based on your runtime environment and your preferences. If you would like to still use packages that are published on some indices, and you want to bypass Thoth's logic that is selecting Python package releases across multiple indices, you can do so. You can configure the resolver to use specifically Python package index, and you can configure this on package level, on package release level. So you are sure that you are consuming the right artifacts in your environment. The way how this resolution process works and how the resolved set of packages are provided to users, the resolver itself is not prone to dependency confusion attacks. So if one index hosts releases of one package and another index hosts releases of a package that has the same name, bumping versions on one package index will not cause that the resolver will use packages from the index that has higher version numbers. So you are really sure that the right artifacts are brought to your environment.
Thoth can be configured to resolve application dependencies without possible dependency confusion attacks. So we are in a project directory, and let's add some dependencies. Let's add a dependency that is called Jim Donkey Car to our application requirements. If we take a look at our pip file that is automatically managed by Thoth, you can see that we have a Jim Donkey Car, and we have some index URL index configuration. This configuration is used by the resolver if we provide disable index adjustment in Thoth section. Okay, so you see this pip file, and what we can do, we can check what indices are available to resolve application dependencies. We can do so by running Thamos indices, and here you can see all the indices that are monitored by Thoth's resolver, and once Python packages are published on these Python package indices, they are automatically used by the resolver to suggest the most appropriate libraries for your application. That's something that can be done. So we can call Thamos advice, and the resolver will consider all these indices and packages present on these indices and will pick the right software to your environment so that the software meets desired quality. So once the resolver computes results, we should be able to see information about Python packages, why they were picked, also metadata about these packages, and if packages are picked from different indices, the resolver also tells why certain indices were used for consuming Python packages. So once the resolver finishes resolution, we should be able to see this information about Python packages. And if we take a look at the log file that was produced by the resolver, you can see that it picked two sources. One is PyPI, the other one is pulp instance on operate first. That is an index for serving Python packages. If you take a look at the log file generated, you see that each package has explicitly index assigned. This index is used for consuming Python packages, and you can also see artifact hashes. These are the hashes of artifacts that are hosted on the indices that are used for consuming these packages. These hashes are automatically verified on installation, so you are sure that artifacts are trusted and they were not adjusted somehow, so they are secure. Now, let's say that we would like to configure our requirements in a way that Jim Donkey Car will be consumed explicitly by pulp operate first instance. In this case, what we can do, we can issue Thamos add a Jim Donkey Car, and we can explicitly assign index that should be used for consuming these packages. If you take a look at the pip file, now you can see that Jim Donkey Car has now explicitly assigned index, and that means that the resolver will use solely this index explicitly if we provide also disable index adjustment to true. Basically, what it means, Jim Donkey Car will be always picked by the pulp operate first index, and the rest of the packages that are available in our application stack will be picked from PyPI org. So the resolution process will be very similar to the one that we've already seen, but this time we explicitly pinned the package to be consumed from the specified index. Now what we can do, we can ask for an advice. So again, we can ask for an advice. I explicitly removed the log file just to see that the log file produced will have these indices, and I adjust it again. So let's wait for the log file to be produced. So once resolve application dependencies, we should be able to see very similar log file to the one that we've already used. So you see, this time the configuration explicitly states how packages should be consumed and from which indices they should be picked. So we can take a look at the log file, and here you can see PyPI.org, pulp operate first, and again, Jim Donkey Car assigned pulp operate first index is used for consuming Jim Donkey Car, and other packages use PyPI for for consuming packages. So now what we can do, we can remove pulp operate first index from our configuration, and we can keep just PyPI as our source of packages, and we can tell the resolver to use solely this source. So if disable index attachment is set to true, a resolver will use solely this source of packages, that is pypi.org. Okay, so what we can do, we can check if we don't have log file. We don't have it, so let's ask for an advice again. And now the resolver will use packages solely from PyPI. So let's wait for the resolver to resolve application dependencies. And this resolution process is done online, so you really see how the system responsive is in case of resolution, and how it is responsive for developers for possible use. So let's wait. And here you see Python packages that are resolved together with additional metadata. And you see that Jim Donkey Car hosted on pulp operate first was removed because it does not respect the index configuration. If you take a look at the log file that is produced, we can check Jim Donkey Car, and here you can see that the package is consumed from PyPI.org in some specific version.
Okay, so that was our last demo that talked about cross-index resolution and how this cross-index resolution can be done sanely and, most importantly, safely. In this section, we will talk about references where you can find relevant documentation and relevant information. The project, as stated, has a web page, so feel free to browse thothstation.ninja. The website has links to various parts, so if you will follow these links, you should find relevant information. If not, feel free to contact us. Here are references to articles that were published. Some of these articles were not mentioned during the presentation, but can be still relevant when checking how Thoth works and how the Thoth resolver can be configured, and how its aspects can be used when using Python and when developing Python applications. So feel free to browse these articles. Some of them are from data science domain, some of them are more on developers' side, some of them are diving into some technical decisions that were done during development of the resolver. If you are interested in sources, feel free to browse ThothStation organization on GitHub. As mentioned, the resolver is fully open source, so you can find all the sources in the organization. Feel free to contribute. The community is open for any contributions. The website was already mentioned. It's thothstation.ninja. The project has a Twitter handle where you can find more information, so feel free to browse Thoth Station Twitter handle, and also feel free to subscribe to YouTube channel where the team publishes technical things, technical decisions, but also technical talks that are done when designing certain parts of the resolver, but also other parts of the project. And you can participate either directly or indirectly in decisions or features that can be brought to the community. The last section links talks and presentations. That's the repo where this presentation will be published. It's available in Thoth Station organization. The repository is called Talks, and I will also link these slides from the description down below. So feel free to check links, feel free to browse documentation, and feel free to contact the team members and Thoth community. This way, I would like to thank you for watching this talk, and hopefully you will find Thoth's resolver and also other parts of Thoth helpful, and feel free to use the resolver. Thank you, and see you next time.